G'day YouTube and welcome back to the ASX Portfolio channel. Now, we are going to be doing something really cool today. We're going to be narrowing down stocks on the basis of value investing. So we're going to be looking at return on equity. We're going to be looking at earnings per share growth and using these factors over a number of stocks to kind of get our list of possible stocks that we want to invest in down to a smaller number. Now, we're going to use the Yahoo Financial data, and we have an API Python module for that, so that's what we're going to be using. And essentially, we could send as many stocks as we want down this API and retrieve that data. So that's what we're going to do. We're going to get the largest amount of stocks information that we can, and we're going to try and, from all those thousands of stocks, work out which stocks we want to spend more time looking into. So without further ado, let's jump in. So first up, let's look at the dependencies. So we have import date time and pandas. So that's usual. Here, I want you to pip install a module called futures. This is going to be used for threading. So concurrent.futures, but just pip install futures if you don't have it already. And then we're going to pip install Yahoo Financials and then import it like this. We're also going to import regular expressions, RE. AST, we're going to need this, so import AST. Import time module, import requests, and if you don't have BS4 BeautifulSoup, import that. We're going to need it for the web scraping. So let's get the list that we want to narrow down. So what is the list and where is it? Well, let's go to this website, ASX 200, for a start. And you can see here they provide an updated list of the ASX 200 stocks. Now, essentially, I want this list. And really, we want lists of as many stocks as possible, but let's start here. So you can see that if you go F12, you can work out which division all this information is, and you keep on going down and down, drilling into the information to try and find out where it is. So web scraping lists of stocks is very specific. So we're going to use BeautifulSoup. So for this, we often need to use a header. I'm finding a lot of websites, the request module isn't working without a header. So please just go ahead and copy this from my website. But yeah, essentially you need to find the user agent, who you are, and that's it. So let's go ahead and actually start implementing this. So let's say first off, we're going to build up a stock list, so that's going to be ASX 200. Now, we're going to need a response. Now, the response we're going to get is from requests, and we're going to call get URL, and the URL we're going to get is this ASX 200. So if we just put ASX 200 in there for now, that will be fine. And then we'll also pass the parameter headers equal to header. So make sure that that has run for you. So once we've got the response, let's look at what that looks like. So we get a response 200. That's cool. Now to actually access that information, what we need to do is use BeautifulSoup. So we're going to call it soup, BeautifulSoup. We're going to pass the response either as a text or as content. Now I'm just going to use text, it doesn't matter. And we're going to use the HTML parser. So now when we get a response, we should see all of this beautiful HTML script. Now the information that we're concerned with is in this table here. So I can see that the class is tabulizer table sortable. So that is what I'm going to find. So the way you do that in BeautifulSoup is you use divs or information that you want to get. You're going soup.findAll, and what we want to find is we want to find all tables. From that, we want to specify the class. So the class is going to be that tabulizer table sortable. Now, we only want to return the first part of the list, because if there was another table that still came under that class, then we just want to get the first element because that's the first table. Then from there, we want to find all of T-body. Now, the reason we want to find all T-body is because under this section, under this class, I can see that there is a T-body parameter that's used to hold all the table information. So we're just subsectioning again. So once we've done all that, we should be able to hit enter, and it says that we've done something wrong with a class, and the reason is it's not class, it's class underscore. Excellent. So now you can see that we have a list here of that T-body table of all our stock information. Now we just want this first parameter here. So how can we go about getting that? Well, we're going to take this as a list. So for I val in enumerate, and we can see that it's a list of length 1. So what I'm going to do is just go divs and take the 0 index, and that's going to give me all this information. Now we're going to iterate it through by line. So let's just do that for a second and we'll print the val. So now we can see that we're getting each line back. Cool. So now what we need to do is actually process this text. So to process this text, we're going to use a regular expression substitute. So what we want to do is we want to get rid of some of the unwanted components in there. So to do that, we have to pass this regular expression, and what we want to do is get rid of anything with T, R, D. And what do we want to replace it with? Well, we want to replace it with nothing. The actual text that we want to process is going to be the string of val. So let's just print that out so you have a good understanding of what's going on there. So now we've removed some of that string, and we can see here now if we split on this backslash, then we'll be able to get our stock. So that's fantastic. Let's go ahead and do that. So we'll go text equals text.split, and we're going to split on that backslash. So great. So now we can see, oh, we've actually got some empty spaces here. So we don't really want that. What we can do there is that we can test if val is greater than 1. So if the length of val is greater than 1, then we'll enter this loop. Excellent. So we've just got the stocks there. Now we just need to add it to our list. So let's go asx.append, and we'll just go text and index by the 0th indexed. So let's print out our ASX stocks now, and we've got all our stocks. So that's great. Now, what happens if we want all of these URLs? Well, that's very easy to do. All we need to do is specify lists for these all to fall under. So let's call the list small odds, and all odds. Actually, let's do it in that order. ASX 200, all odds, small odds, and we need to specify 3 lists now. Okay, so now that we've got that, now we just need to come up with a list that we can iterate through. So ASX list is going to be just a list of these 3 empty lists for now. And what we're going to do is we're going to iterate through this list. So we need the URLs. So we're going to say enumerate again. And we want a list of all of these things. So ASX 200, I'm just copy and pasting all odds, small odds. Great. Now if we bring that in, then we're going to have to take the URL parameter for each of them, and we want to build up the individual respective lists. So we go ASX list, and we can now just index by index. Excellent. So now if we just print out all of those lists now, we should be able to get All Ords list, Small Ords, and ASX 200. So hopefully that helps you with being able to identify a list and then being able to web scrape. So hopefully you can get your own stocks that you're interested in from websites using this web scraping methodology. And of course you'll have to find different tables in different websites, but hopefully you can do that with a find all class structure and just work your way through it. If you get stuck, just print things out as you go along, and remember that there are no mistakes that you can make. So just keep hacking away. Now what we need to do is we need to actually check for duplicates. So the first thing we're going to do is, because I know the ASX, the actual ASX stocks that Yahoo Finance need are .asx. We need to add that to our stock list. So the stock list we're going to choose right now is ASX 200. And I'm just doing that for ease on the video. But again, you could make that as large as you'd like. So stock list equals ASX 200. We need to take the set of stocks. And what we need to do is we need to actually check for duplicates. So we're going to do contains duplicates. And there's two ways that we can actually test this. One, we can actually just count the length of the difference between these two sets and return true or false. So let's do that. So length of stock sets does not equal length of stocks. And this will tell us if there are any any duplicates. The other way we could do this is we could use the any function. So stocks, and we're going to count the elements in the stocks list. We're going to count the stocks in that stock list that is greater than 1. So if we have a count greater than 1 for stock in stock list, then we will get a true back here, and that's not what we want. So if we print out those things now, we can see, hey, you know what, this is false. There are no duplicates, and that's to be expected from the ASX 200 list. But in whatever website you are, you just want to check when you're combining lists that you don't have double ups, because that's important. You don't want double up information. Just make your API slower. So let's use the Yahoo Financial data now and retrieve that financial information. So the way we're going to do this, we're going to create dictionaries that we're going to fill. So we're going to call one balance sheet. We're going to call one income statement, and we're going to call one cash statement, but cash flow. Cool. Okay, so once we've done that, we need to start accessing the API. So essentially what you do is you go for stock in stock list. I did call it stock list in the end, didn't I? Yes, I did. For stock list. Then let's print the stock. And the information that we want from those APIs is held in Yahoo Financials. And we need to initialize the class function Yahoo Financials and stock. So this just passes the stock ticker. Now we could pass a lot of them at once into this API, but that's not the way that I would recommend going about it, because it's incredibly slow. So we're going to pass one at a time, and we're going to speed it up in a second. You'll see how. So now that we've initialized this class, this instance of that Yahoo Finance class, we can actually pull information back from it. So we need the balance sheet data. And what we're going to do is we're going to take this Yahoo Financial instance, and we're going to get financial data. And we're going to, there's two parameters. There's the frequency of the information. So if you're in the States, then you can get quarterly information or something like that. But here in Australia, we're going to get the annual for financial data. And I'm going to pass the second one, which is what financial data do you want? Which financial statements do you want? I want the balance sheet. So get financial statements, sorry, is the call. Now the income statement, for that we just index by income, and you guessed it, for the cash statement we just put cash. Cool. So now that we've actually got those three things, it's probably good here just to, we'll break this loop after one, and let's just print out some of this data. Now, forgive me, I actually called that stocks up there, so we're going to need to go for stock in stocks. And the other thing that I'm going to do, I'm going to actually time this function. So we'll go start equals time.time, and then we'll just print out how long that actually takes. And that will be, and now you can see there that we get this dictionary of balance sheet, or whatever the respective statement is, and then we get another dictionary that's indexed by the stock. Now we kind of want to keep that for ourselves so we can build up our own dictionary. So what we're going to do is we're going to index appropriately. Interestingly, see that it took 17.5 seconds. Now that's absolutely ridiculous. If we were to do that for hundreds of stocks, this would take hours. So we are going to be able to speed that up in a second. So I just wanted to highlight that because that's really important. So let's build up our own dictionaries now. So for the balance sheet, what we're going to do is we're going to create the stock key. So we're going to use the stock as the key, just like they did, but we're going to subsection this data by their parameters. So we're going to index into that key, and then we're going to index into the stock information. So all I want is the list of all that information. Now, just take my word for it. I've printed out the other ones, so we can just index on the respective names, and the respective names are income statement history for the income statement, and for the cash flow, it's the cash flow statement. So just make sure you got the correct dictionaries being indexed. Now, once we've done that, what we're going to do is just run that again and check that everything's okay. Okay, so now that's just incredibly slow hitting the API. It would even be quicker just to hit the financial information and web scrape it, but there are so many bits and pieces of information that I can't be bothered. It would take hours having to work out exactly how to get that information in the right format. So this API is doing us a big favor. But how can we speed it up? Well, essentially we can speed it up by multi-threading. We're input-output limited here with calls to the API, but what we can do is we can hit the API multiple times at the same time. So we're going to do that by threading. Now to thread, we actually need to wrap this in a function. So what we can do is call a function that's going to be retrieve stock. I better just initialize all this as well, actually. So instead of actually having a for loop there, we can just go retrieve stock data, and that's going to take in a stock. So we can still print the stock. We'll probably get rid of the start time and end time. We won't have a break anymore, and we will have a try and exception. So let's try to get the data. If we are unsuccessful for whatever reason, maybe we get the stock incorrect, just like we happened before, then we're going to print an error, and we're going to just say error with retrieving stock data. So that is our new function. Now for multi-threading, what we need to do is we're going to take the start. We are going to time this. So again, start, time, and we're going to have end, which is going to be time.time, and we're just going to print out that function for time taken. Cool. So now that we've done that, we need to initiate the executor, which is going to be our multi-threader. So executor equals, so I think we called it CF, so concurrent futures, and we're going to go thread pull executor. Now, the number that we place in here is the number of threads that we want to create. Now, I'm creating 16 because I believe that I'm limited by my 8 core, which can handle 2 threads on each core. So that's 16 threads at a time. Sometimes you can be limited by the API that you're calling. Sometimes you're limited by the processing capability, but because this is input-output limited, we are using thread pull executor. So hopefully this helps you. So now we've got futures, which is the executor information. So we take the executor instance and we're going to submit the function, which is this retrieve stock data. Now the parameters are the stock for stock in stocks. So that's how we use this pull threading function. So what we're going to do, we also just need to say cf.wait. Wait for all the futures to complete. Okay. So now that we've got that, we can run it, and it will take some time, but you can already see that it's spitting out numbers there. So let's just wait for that, and I'll check back with you in a second once that's finished. Okay, so it's finished now, 322 seconds. So obviously you pass more data, it's going to take longer than that. If you can find a quicker way to import all that data, then be my guest. Let me know in the comment section below, please. And now let's actually save the data file so we never have to do that again. Now, if you're not running Jupyter Notes, it's not going to cache that data, so you're going to have to do that. You're going to have to write this before you start downloading that data. So we're just going to place it into text files. So we'll just open balance sheet ASX 200.txt. Better make sure that that's quoted there. Excellent. Now we're going to write, and we're going to have that as output.write. And we're going to write the string of balance sheet. Now we're going to do that for all the key bits of information. So income statement, and then we're going to do it for cash statement. Better just check that I've named those correctly. Cash statement, income statement. Cool, so we'll put those dictionaries and save them like that. So now that I've saved that data, now I can reference them anytime by opening those data files. So the question is, how can we get our hands on more data so we can analyze? Well, essentially, you just want to be looking for different websites that you can get a complete list or a large list of stocks. So the ASX website, I can get a complete list of all the 2,056 companies that are registered. And so you can hit that there. Well, I think there's 2061 in this list. So I just hit this list, download, and then I'm just importing it with pandas. And you can see here that there's 2,061 stocks within that data list. Again, you should check if there are any double ups or anything like that. But then I would run that function that we've just done for the ASX 200. Again, now that will take some time. It'll take some time, but the multi-threading will help. So what I've done is I've done it before, so we can open these data files. So I'm just going to take you through the code here because I'm conscious of time. So we'll run this file, and I'm going to take from balance sheet and income statement. Now here is where we need to use the AST. So AST literal eval, what we want to do is we want to say, let's read that string, but I want to literally evaluate what it is in terms of Python language. So I want to get back the fact. I want balance sheet to know that it's a dictionary. I want income statement to know that it's a dictionary, because that's what I'm going to use to be able to define on later. Now the crux of it. Now I bet a lot of you will want me to go through this code line by line, but I'm not going to because of the time that it would take. But this is more trivial, I think, to a lot of you who are interested in finance rather than the actual web scraping that maybe you've never done before. So here we're looking at the ROE, which is the return on equity, and the EPS, which is the earnings per share. Now we actually want to get the earnings per share growth and the return on equity, and now they're factors that Warren Buffett is really big on. So if you've read his book or one of his books, then I think it was written by his ex-daughter-in-law, but it is really good at explaining the factors that he uses to apply to businesses and what factors he looks at before he actually dives in to actually doing the analysis. So these are key ones. So this is what we're going to calculate. Again, we can get them from the income statement and the balance sheet. So take a look through this code. I'm just iterating through the dictionaries, ensuring that I have the correct stocks for each of these dictionaries. I don't want to get misalignment between the income statement and balance sheet. And then I'm just taking the net income and dividing by the shareholders' equity to get the ROE. Now for the earnings per share, I'm just taking the profit or the earnings divided by the number of common shares. You can see that all down in here. Now, once I've got the EPS, the earnings per share, what I want to do is actually calculate the earnings per share growth over the number of years. And what you'll see here is that I have to iterate through the earnings per share, and I have to do a couple of conditions. I want to get all the information on the yearly growth numbers, but I also, if there's more than 2 years of financial data there, I want to be getting the 2-year annualized growth. I want to get the 3-year annualized growth and add that in as equal weighting. So really that's what I'm accounting for here. I put them all to dictionaries and I print out some key information. So yearly data available out of that API module was 2013 out of the 261 stocks. Some key data missing. Yes, there was key data missing of 246. Now the earnings per share growth, there were NANs for 864. Now that's huge, and the reason for that is because sometimes the earnings per share came out as ridiculous numbers or zeros, and you can't be dividing through by zeros. So anyway, we'll do with what we can with the data and the companies that we have. Let's apply the conditions on these two dictionaries now. So let's say that we have the requirement of ROE of 10% and above 10%, and then an earnings per share growth of over 10%. So what we can do is we can subsection the ROE dictionary by the items by getting the first item, which is the requirement, making it sure that it's higher than that. Now the second value that I printed out was all of the ROEs, and what I want to show here is consistency, that none of the return on equity numbers was below zero. I don't want to get the numbers that have a really high ROE just because of 1 year of exceptional growth, and that happens a lot with the smaller stocks. So I want to ensure that these are good companies. So I'm just using two conditions here. I also do the same thing for earnings per share growth. I ensure that earnings per share growth does not go below zero. Now, maybe that's not fair, maybe that's a bit harsh, but you can use whatever methods and cutoffs you want to use for this. Once I've got those two dictionaries, all I need to do is do a list comprehension on both of these dictionaries and return the where the stocks are in both of these dictionaries, those are the things that I want to return. And you can see here then we end up with a much smaller list than our 2061 stocks to evaluate. And now from here it's worth further investigation. So hopefully you can go ahead and you can use these Python statements, go through your own stock list and investigate the stocks based on these criteria. So thank you very much for listening. I look forward to the next video, and until next time, YouTube, see you then.